Hello everyone. Today I'm back with one more video on interrupts. I believe the learners would have come across this interrupt word, and I'm pretty sure it's not a new word, probably. So what does this interrupt do? Whenever in your embedded system, any specific part of embedded system needs a quick attention from the microcontroller, that is done through interrupt. If you take a just little meaning of the word interrupt is just stopping the execution or stopping some normal flow and telling that yes, I need attention. Hello embedded learners, I'm Geeta. I work as a technical director at GSAS Microsystems. So today I'll be just demoing the interrupt on how it works on Cortex-M, because I'm doing this video specifically for Cortex-M. So I'm taking the application for LPC1768 and I'll be demonstrating in the simulation. So today I'll be showing this example for interrupt using Keil MDK software, which is a modern embedded software used by many developers worldwide for any ARM-based microcontrollers. So during this demo, I'll also be telling what needs to be taken care by a developer who wants to develop an interrupt program using Keil MDK software. So please pay attention. So now let's get into the software. So now let's see the demonstration of how the interrupt works on LPC1768, which is based on Cortex-M3 based processor from NXP. So to demonstrate that, I'm using the IDE, which is popularly used by many of the developers worldwide, none other than MDK. Keil MDK software. So here I'll be showing how the interrupt can be developed, and please pay attention. I'll also be telling how you have to develop the software for handling or writing an interrupt for any of the peripherals or the peripherals which can generate the interrupt. So today my focus is on external interrupt, and I have taken this sample project from ARM for one of the boards, which is based on LPC1768 and the board is MCP1760. So please pay attention and don't miss any details. So now after launching the Keil IDE, I'll open the project. So go to Keil, installed folder, go to ARM, boards, and go to Keil and select 1700 and EXTI. So please remember, this project is being developed by ARM, and I have not developed it, but I'm using this specific sample project for the demonstration purpose, because any embedded learners want to just quickly understand how the interrupt works. They can quickly install the software and they can start working on it. Or you can use this as a starting point for developing on your application. So basically, this project is based on this LPC1768 Cortex-M3 MCU. There's a board. On the board, we have a X-interrupt 1 switch, which is connected to GPIO port 2.10 pin. And by toggling this specific switch, that is pressing the switch, it will generate an interrupt to the microcontroller. So the beauty of this demo is I'll be showing it in the simulation again, where I'm not connecting any hardware. So that's a very interesting part to note. So as usual, I'm not explaining the program. As usual, the program starts executing from the main, and I have written the EINT3 handler. P2.10 on LPC1768 is connected to the X-interrupt 3. One thing to note is LPC1768 supports 4 X-interrupts. So in that I'm using EINT3. Well, so now you may ask me why this specific function name. Though I have covered the necessity of matching this function name in my videos on debugging the exceptions in Cortex-M3, I'll be again touching it upon. So please go to the startup.s, and there if you come to the dummy handlers, so you can see it is EINT_IRQ handler. So this function name should be maintained. Or you don't want to use this, you can still modify that in the C program. Suppose I want to give external interrupt _3. can give whatever function name. So that function name has to be modified back in the startup code. So if you don't do that, processor will not understand, yes, there is an interrupt generated in the system. So to synchronize and for the processor to understand, because this function name is the way to tell to the processor where it is find the handler for this specific interrupt. And these are nothing but the entry to the handlers, kind of exception or an interpreter table you can consider. Right. So in this handler, I'm just toggling a specific port pin, that's it, because it's a demo program for that board. And if required, I can, based once the interrupt is generated, I can also blink the LEDs which are connected on the boards. It's up to the user. But just to demo on the interrupt part, I have taken this. So now let's build the project. Done. Now we will enter the debugger. Right. So you can see now my program starts from the main function. Because I'm using in simulation mode and there is no, but I don't have any hardware to generate the interrupt, so I should do it through simulation. So how do I do that? For that, first open the peripherals, core peripherals, nested vector interrupt controller. NVIC is a very key block in the MCU core which helps in managing the interrupts, handling the interrupts or exceptions, even nested interrupts in that matter. It's very well designed by the ARM team to ensure that interrupt handling processing happens in a smooth way without causing any additional overhead on the processor. Well, so after this, I'll be using this toolbox again. Right, I'll tell you what is this toolbox. Next, I'll be going to okay. So now in this NVIC, now when I run the program, it will enable the nested vector interrupt controller and it will run the code. So now to show you that microcontroller comes to this external interrupt handler, I'll put a breakpoint. Just put a single click on the gray area and it sets a breakpoint. So now when I run the program, you see in the NVIC, I should come to external interrupt 3. So you can see here, selected interrupt, though it is enabled by the register, but still this processor is not aware that there is some interrupt which it can expect in any moment. So for that, I have to click the enable the interrupt. Interrupt will be generated. Now I have to toggle that P2.10 pin. So to do that, I click this button. So as soon as you click this button, EINT0, you can see the processor comes and stops at the hex interrupt. So what is this button doing? So to see that, so you can see here. So first I'm configuring the port to pin select register to, because P2.10 pin is a GPIO pin. So now I have to tell to the microcontroller, please use P2.10 as a external interrupt 3 pin and not a general GPIO. So that you can do it from this port to register. And then here in push EINT0, this is a function, signal function which executes in background. Here I'm toggling that specific bit, P2.10. If it is high, I'll make it as low. If it is low, I'll make it as high. And to make it more user-friendly, we have just, you can toggle this directly from here as well, P2.10. But to make it as more user-friendly, we have written this button. So it's just easy, define the button, give the name for the button. And when you click the button, what is the action the IDE has to take care? So what is the action the IDE has to do? It has to invoke the function push EINT0. Because as in C, programming, until you invoke the function, your processor will not go to that, or that particular function will not come into execution at all. So this is the signal function which executes in background. So now when the processor comes here, and let's just give single step, so it will toggle a bit on the port 2 and That's it. This is a simple interrupt example on how NVIC can be enabled. And main thing is testing the code without connecting the hardware and using the simulation features which are being given by the ARM team. Very powerful simulation features which can be used by the embedded learners, which I would motivate and encourage the learners to use it. So now coming to the task, select any of the microcontroller which you want to use, be it 8051 or it can be ARM or any microcontroller depending on what IDE software you are using. First check whether that software supports the simulation of the interrupts, or if you already have a hardware prototype board, simple board developed with the interrupt button or something connected, then go ahead and use that software along with the board and ensure that the code what you're developing is loaded to the board depending on what MCU you're using. But I would recommend to go with Cortex-M3 and ARM, because MDK gives all the simulation features, very powerful features. And even if you don't develop the board or to understand the basics of interrupt, how the programming can be done, yes, MDK would be the best choice for you, because you can simulate even without connecting the hardware how my code works, how my application what I've written handles the interrupt, how MCU can handle it. I'm sure this video would have given you an idea on how the interrupts can be implemented and programmed in MDK, and how it can be tested on simulation, or if you have hardware also in real time, and see how it can be executed. Thanks for watching. I'll see you soon. Bye bye.